We present a new self-supervised framework, Pose Triplet, for 3D human pose estimation. Human pose estimation is to estimate 3D pose sequences from videos. It has many applications such as action recognition, virtual try-on, and mixed reality. Conventional fully supervised methods such as direct 3D regression, two-stages approach, and SMPL regression mainly rely on ground truth 3D data for fully supervision. However, the supervised training requires large amount of data, and capturing 3D pose data is cost-intensive and time-consuming. In the problem setting of only 2D pose available, self-supervised methods has been proposed. However, those approaches mainly rely on weak supervision such as self-consistency or reprojection loss, results in unstable and inaccurate prediction. To address this issue, we propose a self-supervised framework, Pose Triplet. It utilizes the estimator, imitator, and hallucinator in a dual-loop co-evolving manner. Pose Triplet can generate physically and semantically plausible 2D-3D pose pairs, so that full supervisions can be imposed to strengthen the self-learning process. In detail, the estimator lifts 2D pose to 3D pose. There are three advantages. Firstly, GT2D3D pose pair can be easily obtained from random projection. Secondly, there are many off-the-shelf 2D detectors such as OpenPose, AlphaPose. Thirdly, the trained pose estimator are capable to unseen motion. Trained indoor dataset, it can be applied to outdoor scenarios. The limitation are artifacts such as foot skating, ground penetration, jittering. The imitator takes noisy reference motion as input and outputs physical, plausible motion. The advantage is that it can provide physical correction for reference motion as shown in the video. And the limitation is that without reference motion, it will result in a semantic implausible motion as shown in the video. The hallucinator can generate diverse motion based on plausible motion database. The advantage is enhancement of data diversity. The limitation is it requires additional physical correction for artifacts such as feet skating. In summary, the estimator can predict motion with reasonable semantics but implausible dynamics. The imitator can correct the implausible dynamics but requires semantics motion guidance. The hallucinator can enhance its data diversity and thus better generalization but require motion database. This shows that estimator, imitator, and hallucinator are complementary to each other. Therefore, we propose Pose Triplet to utilize the advantages of estimator, imitator, and hallucinator. The estimator converts 2D poses to implausible 3D motion. The imitator generates plausible 3D motion by adding physical correction. The hallucinator acts as a generator to diversify the motion, which is then fed into the imitator and generate diverse plausible motion as training data for the estimator. In this way, the three components work in a dual loop, forming a co-evolving framework. Here is imitated motion from rounds of co-evolving. The estimator and imitator get improved over rounds of training, and thus the imitated motion becomes more accurate and realistic. Here is more imitated motion from H36M. With given only the 2D motion data, Pose Triplet can recover all realistic 3D motion. And based on the imitated data, Pose Triplet can hallucinate much more novel 3D data as shown here. These data are feeding back into the co-evolving framework, which in turn reinforces all components in the loop. We compare our method with the state-of-the-art approaches. From quantitative view, our method achieved the best performance among self-supervised methods, and comparable performance with fully supervised methods in the cross-data and in the wild setting. From qualitative view, our result is much smoother compared with whose result, and provide more stable body size estimation compared with whose approach. Here we demonstrate more results for in the wild scenarios, such as dance or sports. Our method achieved a good generalization performance for pose estimation, and more imitation results for in the wild scenario. With physical correction, the imitated result are more natural and realistic. Thanks for watching. For more detail, please refer to our paper and code.